Okay, students, in this video, we will be learning about movements of ocean water, and here we'll be learning about different types of ocean currents and tides. So we'll see the content, what are the topics that we are going to learn here. Starting with the introduction, we'll be discussing about the meaning of hydrosphere, classification of ocean currents, and the factors affecting ocean currents, and we'll also be discussing about the some major ocean currents, although there are many other ocean currents, but we'll be discussing some few. And lastly, we'll be discussing about the tides. So let us start with the introduction and meaning of hydrosphere first. So generally, hydrosphere is a combination of two words, hydro plus sphere. And hydro means water and sphere means spherical. It represents the earth, spherical earth. So it means a water found on the spherical earth. So there are all forms of life on the earth that directly or indirectly dependent on water for their survival. So we cannot think of any kind of weather and climate change without water. So water plays a very important role here in changing the weather and climatic pattern throughout the world. So hydrosphere exist in different forms, solid, liquid, or gaseous forms. Okay, so and it also says that 3 by 4th, that is 3/4 part of the earth is covered by ocean, or you can say is covered by water. So let us draw a diagram here. So okay, if we categorize earth, or if we classify earth into four segments, then this part is covered by ocean, and only this part is land. That means majority of the earth is covered by water bodies. Okay, now coming to next, uh, that means about 97% of the surface water is in the ocean, and 2% that is in the form of frozen, that is in the frozen state, that is at the polar ice sheet, in the form of polar ice sheet. Okay, and less than 1% is fresh water. So remaining 1% is used for potable water, or maybe it is used for domestic purpose. Okay, so that means only 1% is used for domestic purpose. That means the use of fresh water, although the use of fresh water is more, but the reserve of fresh water is very less. That can be in the form of groundwater, or in the form of lake, rivers, etc. Now coming to next, movement of ocean water. So generally, how to define an ocean is simply a huge mass of water bodies. Okay, it's just like a, say for example, it's just like a swimming pool, or it's just like a water that is filled in a tub. Okay, but there can be different kind of movement on this. Okay, so due to maybe because of maybe because of wind, or maybe because of salinity or temperature. So generally there are three types of movements. They are wave, tide, and currents. Now waves are generally the rise and fall of surface water due to the friction of the wind. Okay, so a wave can be seen in ocean, wave can be seen in any kind of water body. So it's simply rise and fall of ocean water due to friction caused by the wind. Okay, and next is tide. Tide is also rise and fall of sea water, or the sea level, due to the gravitational pull of the sun and the moon. So due to the gravity of the sun and the moon, the sea level rises up and falls down at particular interval. So that is what we call tide. Now coming to next, ocean current is quite different phenomena. That is, ocean current is simply a large movement of water, or mass movement of water in a uniform direction, or in a definite direction. Okay, now wave and tide has a greater influence along the coastal areas, whereas the currents has influence over a large part of the ocean. It not only impact the coastal areas, but it impact the other major part of the ocean. Okay, now coming to next. So regular pattern of ocean movement of large mass of ocean water in a definite direction is termed as ocean current. So this can be the definition of uh, ocean currents. Now coming to next slide, that is movement of ocean water based on direction and velocity. So I have not mentioned here velocity. So that is based on direction and velocity. There are three other types of movement, that is drift, ocean current, and ocean streams. Now what are all this? Now drift is simply the movement of ocean water that is under the influence of prevailing wind. So whatever the prevailing winds are there, prevailing winds or the permanent winds, so we have already studied about prevailing winds and permanent winds. These wind never changes its direction. It flows in a uniform direction in but that particular location, like trade wind, say west wind, drift. These are some of the name of the uh, say west wind, or maybe the wind that blows in the eastern directions. Okay, or easterly, whatever we say. So what is drift exactly? It is the movement of ocean water under the influence of prevailing wind. Example for drift can be west wind drift. Okay, that is carried out by the west wind blowing from the western direction. Now coming to next, ocean currents, as we have already discussed about this, it is the movement of ocean water in a particular direction with greater velocity than the drift. So drift is the slowest movement of water, we can say, compared to rest of the two. Okay, so it is little bit, ocean current moves a little bit at a higher speed. So example of ocean current can be Labrador current, Brazilian current. Okay, and there are other more currents like Kuril currents, Oyasu currents are examples of this. Now coming to next, ocean streams. Now what are ocean streams? These are the huge mass of ocean water. It's just like a big river on the land that moves in a particular direction. Okay, so ocean streams moves with greater velocity or speed than compared to the above two. Okay, so it's just like a river on the ocean. When the huge mass of water moves in a uniform direction at a greater velocity, then it is termed as ocean streams. Example can be Gulf Stream. The speed of the Gulf Stream is quite high. Okay, quite more compared to the other two. So these are the movement of ocean that is based on direction and velocity. So you may be asked, classify movement of ocean currents, movement of ocean water based on velocity and direction. So on that note, you can write these 3 points, three types: drift, ocean current, and ocean streams. Now coming to next slide, that is classification of ocean currents. Now ocean currents are basically classified based on temperature. So there are two types of ocean currents: warm ocean currents and cold ocean currents. So this classification is based on the temperature. So here we have one hypothetical diagrams that will try to make you understand the concept of cold current and warm current. Now you see here in this diagram, this part in the eastern and western extent and the eastern extent, there is land body. Okay, and this represents equator. This portion represents equator, and as you move away from the equator, temperature also reduces here too, same. Now look here, the as I already told you, the current is, the ocean current develops due to prevailing winds, or the ocean currents are carried out by the prevailing winds, right? Now earth rotates from west to east. Okay, due to which the trade winds blowing from this direction, from subtropical high pressure belt towards the equatorial low pressure belts, gets deflected and it starts moving towards this direction. So when it moves towards this direction, then what happens, the trade will try to carry the surface water along with it. Now this surface water, when it moves towards the eastern margin of the continent, or when it moves towards the western side along the eastern margin of the continent, then it will try to bifurcate towards the northern side and the southern side, because here we have land body. Okay, let me tell you one more thing, that is uh, regarding the property of land and water, heating property. Okay, so land heated up very fast compared to water. Okay, and water takes times to heat, and it also takes time to release its heat. Okay, so this is the property of water and land in terms of heating. Okay, now you see equator is a region that receive maximum insolation, so thereby the temperature is more in equator, although the temperature of the water or land. So here you see the temperature is 30 degrees Celsius. Let me talk about the warm current first, A, which is marked with A. So here the warm ocean currents, when it is in the equator, okay, it will try to move towards the poles. Now as it moves towards the pole, let us consider this as uh, sorry okay, now let us consider this as 45-degree latitude. Okay, and this as 45-degree latitude. Okay, let us discuss only in the northern hemisphere first. Now this wind, when it moves towards the eastern margin of the continent or towards the west, then what happened, it is obstructed by the land body and it will move toward the northern side and the southern side. Okay, now here you see the temperature of the land is 30 degrees Celsius and the water is also 30 degrees Celsius, because it is in the equator. Now as you move towards the uh, latitude, 45-degree latitude, the temperature of the land is 20 degrees Celsius. Now here temperature is less compared to the equator, but the same water, when it moves towards the 40-degree latitude, then it will release its heat reaching up to that latitude, so thereby the temperature will reduce by 25 degrees Celsius here. Now in the same latitude, if you compare the temperature of the water and the land, you see the temperature of water is more. That means it is a warm ocean current. So for that particular reason, it is a warm ocean current, because the temperature of the land is 20 degrees Celsius, but the temperature of water is 25 degrees Celsius. So we consider this point, we consider this latitude, this water moving towards latitude 45 degree is a warm current. Okay, now the same ocean currents reaching up to the northern extent, here we have land body. So this is why this ocean currents will bifurcate or again change its direction towards the east. So when it reaches migrates toward the east, then the water body that had a temperature of 25 degrees Celsius will reduce to 20 degrees Celsius, that is decrease of 5 degrees Celsius. Okay, now in the latitude 45 degree, the land temperature was 20 degrees Celsius. Now it is equivalent to that water temperature. Now the same water, when it is obstructed by the land body in the eastern margin, it will move toward the south, towards the equator. So as it moves towards the equator, the temperature of this water, let me show you once, the temperature of this current was 20 degrees Celsius there in 40-degree latitude, but when it migrates towards the, or when it moves towards the equator, the temperature gradually rises, because as it reaches towards the equator is a warm region, so here the temperature of the water will increase by 25 degrees Celsius, but compared to the land temperature, the temperature of the water is less, whereas the temperature of the land is more. So we consider we consider this current as cold current, because here it is reaching to the equator, but the temperature of the water is less compared to the temperature of the land, so thereby it is considered as cold current. So that means the water that moves towards the pole is a warm current. The water that moves towards the equator, from the pole towards the equator, is a cold current. Okay, so this is how we have to identify the warm current and cold current. So always there is a rules, or you can say it's a kind of a kind of theory type, that ocean water moving towards the pole is a warm ocean current. Ocean current moving from polar direction towards the equator is a cold ocean current. So this is how you can identify the warm ocean current and a cold ocean current. Now coming to next slide, that is factors affecting movement of ocean currents. So there are generally 6 factors: planetary wind, salinity, temperature, rotation of the earth, shape of the land, and seasonal variations.